Let's spend this section converting our users from the C shell to the bash shell, since it's more standard, it's used across the board with other OSs such as Linux and other Unix distributions, so it's more standard. Instead of logging in as a non-privileged user, we'll do so as root so we can make the changes, since UCBT isn't a member of the SU group just yet, which will influence later on. So the idea here is to update the various shells to bash, standardize on bash. Again, as we echo the shell, which is a variable that's maintained, it reflects that it's C shell. That means it's not as configurable and as flexible as the bash shell. So with that said, let's open our notes file, gedit, UCBT, and we're looking for the UCBT notes file. Now, just a quick recap if you're not familiar with Unix. What we've just done is echoed to the shell that we'd like to execute gedit, followed by tilde. Tilde is a built-in variable, which means the user's home directory, followed by the name of a file. So it's just a shortcut. It's an alias. This will bring it up in the foreground, and we can continue to write to the file. So our interest in this section is to convert users to bash shell. We'll use the variable reference. So the bash shell features command history as well as a number of other items that make it superior to the C shell. In fact, the bash shell is the latest incarnation of the best shell available because it incorporates features from Korn, C shell, as well as the Bourne shell. So what's required? Well, features, as we've mentioned: command completion, history, job control, compatibility with other Unices, which of course includes Linux. So in order to make this happen, we of course have to install the bash shell from the ports collection. So our first task is to install bash from ports collection. The ports collection is located beneath the user tree, user ports. And one quick way to determine where bash is in the tree is to execute where is bash. This will tell you where it's located. So let's open a separate shell. Control-Shift-T will bring up a new sudo terminal number 1. So where is bash returns that it's located in user local bin bash. So this actually shows that it's available on the system in user local bin. And in the ports directory, it's beneath user ports shells. Now to compile this is what we'll have to carry out. We'll navigate into user ports under normal circumstances, shells, bash. A number of shells are available. And you execute at this stage a make and a make install. Now this will download from the internet the bash program and any other dependencies required by the bash shell in order to be operable within a FreeBSD environment. And if all goes well, we execute a make install. So let's just update our notes. So where is bash? User local bin bash, as well as user ports shells bash. 2, cd into user ports shells bash, followed by a make, followed by a make install. And then bash should be available in user local bin. So this will provision bash in user local bin as simply bash. And then we'll have to update each user's account using chain shell or modifying the etc password file directly. Now, bash, as well as many other ports, are installed in the non-mandatory user local structure, user local in this case bin. Binaries that are beneath /bin are mandatory in order for the system to operate. So bash can be considered to be an ancillary, non-mandatory, non-required binary. So bash is an ancillary, non-required binary. Thus, its location in user local bin in this particular case. Now let's see what's happening. So this looks good. So it's been compiled. Now let's make install, and that places it in user local bin. And if it's already there, then it tells you that's already found. So it knows that it's already installed. Now let's do a where is again. So in your system, this is what you do if bash is not installed. In our system, it happened to be. But we'll just cycle through the process just so that you know what's required. So this tells us it's in user local bin, and the man page is available in the following directory, user local man. So that means bash is available. However, it's still not our current shell. Let's echo our shell. It's still the C shell. To make it our shell, one method is to use the change shell command. So using change shell, and let's just show you that. We'll do a which change shell. It's in user bin, and if we execute change shell with help, you'll see that one of the options is to specify directly the location of the shell. An optional option is to specify the user for which the change should be affected to. Items that are between brackets are optional, so if you don't specify, then the changes take effect on the local user. So change shell user local bin bash for ourselves. So this will update the current user's shell to bash. And then we can alternately make the change to, or additionally make the change to the user Unix CBT. So let's change shell user local bin bash. And this will do it for the local user. Now, how do we know that the change has taken effect? Well, whenever you execute a command, you can echo the question mark variable to ensure that the command operated as expected. So if a 0 status is returned, then that means the command was executed successfully. So note echo question mark after each command invocation to determine success or status of recent invocation. And we should also note that if exit status is equal to 0, this almost always means that the invocation was successful. Almost always, because there are times when scripts are poorly written that 0 is returned when the exit code was really something else. But the shell doesn't seem to be reflected. Let's echo the shell again. It's not reflected. That means we'll have to launch a new sudo terminal, or a new terminal that's connected to one of the consoles, a virtual terminal, in order to see the changes. But to confirm from a password file perspective, let's grep root from etc password, which is world readable. And notice that the user's shell is now set to user local bin bash. Let's grep Unix CBT from the same file, and you'll see that the user is still set to use the normal C shell. So it's been updated for root, but we don't see the reflection of that. Now let's exit this instance and open yet a new instance. Let's echo the shell. Notice, still no reflection. Why? Because it's still reading when the GNOME session was invoked, it read and kept in memory certain items such as the shell that the user is to use. So we still have a login session. The way to fix this is to log out and log back in, or to try an SSH instance. Now, before doing all of that, let's also update Unix CBT's shell. So we'll do the same command, change shell, user local bin, and you can use tab completion with this enhanced version of C shell. And this will be affected against the user Unix CBT. Now, if this command is successful, we'd like to have the exit status echoed. And if that is successful, let's also grep Unix CBT from etc password to be sure that the user's entry has been updated. Indeed. So now the user Unix CBT will use the bash shell. So how do we prove all this? Well, let's close gedit, log out, and log back in to see the new shell. Now again, if you're wondering, what if we simply just close the terminal and open a new instance of the terminal and echo the shell? We see it's still the C shell. That's because, again, this is one login session that's consistent with the previously defined shell, which is C shell. So let's log out root. We have the option also to switch user. And we'll log back in as the user root, since that's the user with whom we were working. And momentarily we'll open a shell, which will generate a fresh sudo terminal. And now notice the difference in the prompt maybe subtle, but it's significant enough. Instead of simply UCBT1, which is the host name, the bash shell reflects more meaningful information in its prompt. We'll copy this and paste into our notes. But again, let's now echo the shell, and you'll see that it's user local bin bash. So our shell has been updated. Now let's gedit to update our notes, UCBT and the notes file. And just note, after changing user's shell, re-log in to confirm, using, of course, an echo of the shell. And we see, for example, that this is the output. The bash shell is highly configurable. In this particular case, the variables that are at play include the user's name at the host name, as well as the current directory, which tilde means is the user's home directory. So note, tilde at the shell means the user's home directory, which of course is also a variable. To see the list of variables that are available, simply use print environment. So print env dumps the currently defined variables for the shell. We use the variable because it pertains again to the shell that's in question. So let's Control-Shift-T. This TTY is pseudoterminal1, and let's print environment. We'll tab it out. And here are the variables that are defined for this particular shell. So you can scroll through these to get a sense as to what's referenced. Important ones include, of course, the home directory for the user, the login name, the username, which is also the same as the login name, which tells you who's currently logged in, user, which is also the same. So we've now updated that user. We can also confirm the user UCBT. And let's log out of root's GNOME desktop environment. And this time we'll log back in as user UCBT1, or simply UCBT, listed as the user UCBT1. Notice the prompt differential. Let's echo the shell. Bash. Excellent. Let's dump the environment. There are the variables. And let's gedit. And it's not in the history. It's the first time we've invoked it, so we'll just edit it this way. So this works as well. Let's just also note, in the event that you're not familiar, that bash uses a hash mark terminator for privileged users prompt. The privileged user is, of course, root, whereas bash uses a $ terminator for non-privileged, which means everyone else, users prompt. That explains why, when we examine the shell, let's open another pseudo terminal, that the prompt terminates with a $ versus a hash mark or the number sign. That's one visual way, in the event that you're shoulder surfing, to determine whether or not root's logged in versus a non-privileged user. Also notice that we were able to update the file, which means the permissions were not changed as a consequence of opening the file as user root. So now we have the bash shell. We can benefit from all the features included with bash. And this is, of course, the latest version of bash that's available in the ports collection. One quick note on the ports collection, that is, when you install a full ports collection, you don't actually install all of the code and all of the dependencies. You simply install the make files and references, the environment that is required to compile the particular software on your instance of FreeBSD, which is why we saw references out to the net to download bash and so on. Let's just tell this not to show us any warnings regarding space. We'll extend the space later on. So now we have bash running, and it is available. Now, there is a file. Let's take a look. etc shells. This file must contain all of the shells that are possible or may be used or acceptable for your system. By virtue of installing bash via the ports collection, an entry was made for us, which allows bash to be used by any user. If the shell, in this case bash, is not listed in etc shells, and this applies to Linux as well, then the user will not be able to use that shell to connect to the system. So because this is here, we're able to use bash as well as C shell, TC shell, regular bourne shell, and so on. So that's what's currently set up. Now when you define users, you can specify the default shell. There are defaults. You can indicate that bash will be the default going forward. As a virtue of installation, FreeBSD does not provide bash by default, so we've of course compiled initially the bash ports sources to make it available for our usage. So that's how you set up bash. Now what we'll look at next are many of the basics of driving any Unix system.